Testing. Oh yeah. Working? Yeah. Hi everyone, I'm Billy. I'll be the session chair for the Cool and Gather Room today. Just to start us all off, can we all sort of group together in the center? I know you're all antisocial, but it's all good. So for today, I'd like to introduce Wayne Phillips from SentinelOne, talking about the autonomous SOC revolution. Thank you very much. Please make him feel welcome.
Thank you. Well, I know there's a few other sessions on, so thank you very much for spending the time with me. Can you do the slides so I can? So before I do that, basically this segment I wanted to talk about like SOCs or managed detection and response, and like it's something we all have in common, right? Even the sound checking guys sorting out the slides. Right, we all rely on MDR and SOC, and it's becoming increasingly important that we do that properly. Yep, I heard you. And even if you think of, or you look at the banking ads, like 80% of the banking ads these days are telling you that we have, the best security operational center. You'll have the ANZ Falcon, CBA, you'll have, the Macquarie Bank Hedgehog protecting all of your things. Right, so companies are now, telling customers how good their SOC is, right? So it's something that really is becoming increasingly important across all industries, right? And we all have that in common, right? So you need to make sure that you can understand and articulate the value proposition of a SOC. You then have to go and buy one, you have to build one, or you have to in-source one, right? So running a SOC is incredibly important. So what are the current SOC problems? So long queues, right? If you're a small organization, that's pretty small. But if you're an MSP or an MSSP, this can be an ever-moving list of alerts come through. And complex systems. We used to have a couple of endpoints, a couple of servers, firewalls, and Wi-Fi. Now you have massively scaled out virtualization. You have Kubernetes. You have containers, and that over a disparate system that's continuously moving. You have containers spinning up, spinning down, auto-scaling, so it's becoming really complex. And now you've got applications predominantly in the cloud, right? So how do you protect all of that, and how do you run a SOC across those ever-moving environments? We don't have enough time, right? That could just be an artifact of resources. And then talent shortage. I think this is a bit of a misnomer. Everyone in the room may or may not agree. To do like level 3 triaging of incidents, it's not that we don't have the people, it's just that's rocket science. Like it's so hard to like do reverse engineering of malware using Ghidra or something. So like, yeah, we can get some graduates out of school, but they're not going to be able to triage level 3. So it's that level 3 analyst and above, malware, reverse engineers. That's the shortage, right? We have enough people. So how do we fix that? So I like to start with streamlining this security workflow, and it's just start with there's a storyline detection on the endpoint on the left-hand side, and then okay, let's analyze this. Okay, what user was affected? What machine was it on? So let's have a look at the machine. Is there any artifacts there? Was there any process migration as it moved to other processes? And then you start going, well, what user was involved? Okay, well, I've got this interactive user. I've also got some services. So I've got some interactive, I've got some non-interactive, non-human identities. And then you go, okay, what groups are they in? So you start moving across this chain. Where did these users log in from? Are there any other systems? Have they moved laterally? Do they have credentials? Are they logging into other boxes? Are there any behaviors that are abnormal, right? So that's the identity part. Okay, what other systems do these identities have access? Do they have access to cloud? Can they move laterally or find out the attack chain through your environment? Are there any vulnerabilities there? And so on and so forth. Now I'll just start by saying, do you think this is something you could workflow? Like, yeah, you could workflow this. So if you look at the SOC of the future, where we have generative AI and agentic AI, which I'll go into a bit later, you could definitely have this as a workflow. You have an incident or an endpoint, then agentically work out what the identity is doing. Agentically work out where they're logging in, is that behavior at normal, right? So you could map out this workflow, so you could automate all of this in a sophisticated way rather than just scripting it and having saw rules do this. So we'll leave that for later. But to do this, you'll need to have all of your surfaces covered. Here I've got endpoints and identity. Obviously those two are critical, having all of your services with some sort of agent collecting telemetry. And today, with email business compromise and social engineering of accounts and just accounts being leaked on the dark web, identity is critical, right? So our environments have got pretty secure over the years, so people are just starting to attack the user and just getting the user to do dumb things, to put their password in, and then you can log in as the user, and you don't have to break in, you just have to log in as the user and get all their data. Exposures, like the CVs, CVSs, things like deception, if you have it, get that data in, and then third-party security tools and your cloud data. That could be telemetry, or it could just be the data that's in the cloud. You kind of need that into one place, whether that's a SIEM, a SOC, because you're going to have to triage all of these attack chains, and they have to have context, and you have to knit this together. So it would be really good to have some sort of natural language interface to work out and analyze this data in natural language. And it's definitely real. I'll try not to talk about SentinelOne in our product, but we have generative AI in the product. And 2 weeks ago, I used this in a live fire exercise, and it was a game changer. It just, as a SOC analyst, it took 5 minutes, what would have taken me 4 hours to knit these scripts together. And I was able to show a brigadier the 4 IP addresses that the red team were using in about 5 minutes, and it was a very large cyber range. So an inflection point. So the attackers, the bar to entry is lower and lower and lower. Now they've got generative AI and those tools that we use every day to speed up their attack chains. People are really worried about deep fakes. I'm not worried about deep fakes. You can be, that's fine. But we have an MDR team, so over the last sort of 6 months, we haven't seen an uptick in deep fake attacks. We're still seeing the general email business compromise, the ransomware attacks, right? That is still 80–90% of the attacks that we have. The thing that I came to the conclusion is deep fakes, it's actually still targeted, and that takes time. And maybe you've got generative AI tools to improve that. But if it takes 5 minutes and an attacker wants to attack 5,000 people, right? That's, the proof of work, right, is still high. The work rate for the attacker is still high, whereas ransomware is almost, no cost to them whatsoever. And you actually need to run these on something, right? So if you're building a Gen AI model and then you're running that, there's compute involved, right? There's heavy compute. So to do the deep fakes, doing one at a time is good, but you can't scale that. So I'm not worried about that. Thing I'm worried about is attackers using agentic hyperautomation, right? That is scary, and I've seen that, and it's like, okay, this is, so the worst is yet to come, is basically what I'm saying. So info stealers, again, the attackers are now trying to attack the humans or the browser. All right, if they can get a browser extension in or an info stealer into the browser, all of your cookies, all of your passwords go into the browser. And we have seen over the last year a big uptick in info stealers on Mac OS, because, born in the cloud companies use Mac, and all of the data is in the cloud. So if they can compromise those users, they don't need to be in an environment, they can just log in from anywhere. So we're seeing a massive uptick in info stealers. And the different techniques and tactics are improving or increasing at a rate of knots, right? So I work with our product team to try and get all of the new detection engines done, and it's a rate, we've done an incredible amount of work over the last 6 months just keeping up, right? It's, we build mechanisms to try and reduce the inoculation time, which is a time where a variant or a technique is discovered, and when a user can actually detect that, we try and shrink that. And there's a lot of techniques we use to try and improve that. Things like auto updates for static AI and behavioral AI engines, so we can do that over the air. But as you can see, the different the tactics going from 50 to 64. So there's 14 different new tactics, and obviously within that there's sub tactics, and then there's obfuscation in that. So And then, even containers alone went from 28 to 39, right? So that's a big uptick in the types of attacks. So, the SOC and the MDR, you can't just go to a company and go, I want you to look after my incidents, and we'll give you an SLA of 1 hour, and then you walk away with a price and think that's good, right? You would need to analyze what's in the service, how that service works, and how effective it is, right? Sometimes if the company misses their SLA, you might get some credits back or a free toaster, but your infrastructure's hosed, right? So the risk is massive, and these are the kind of people that are attacking you. I only came to this realization a few days ago, but there's a lot of weather in there used to be animals like fancy bear, and now we've got some weather going in these names. So forest blizzard, which is the Russians, right? They, a new name for the Russians. Fancy bear was the old name. So forest blizzard are using LLMs against us, improving reconnaissance. So they are using these, but to improve their attack. Emerald sleet, another weather one, is the North Koreans. Probably my favorite hacker group. North Korea is massive. You think it's a tiny island, but they have companies all around the world, right? So there's a lot of OSINT out there. Do some research. There are North Korean companies in the US, China, all the way through Europe, right? They're a money-making organization, and I think they've stolen more Bitcoin than all of the other money bank robberies in totality, right? So they've stolen more money than any of the bank robberies, across the globe there's ever been, right? So the amount of money that they have in Bitcoin is incredibly big, and they're continuous to use that money to fund their crimes. Sandstorm, Crimson Sandstorm, obviously it's the Crimson, so that's the Iranians, and then charcoal and salmon typhoon, right? So now we have the salts and the typhoons, right? So the Chinese, the CCP, probably one of the most sophisticated attackers out there, with 500 million hackers at any given time, right? So just let that sink in. 500 million people hacking on behalf of the government or related to, and that's just the nation states, which is almost impossible to stop if you're in their line of sight. And then we've got the e-crime, the normal sort of financially motivated or script kiddies, script kiddie attackers. They're also using LLMs, right? So these very sophisticated attackers are using these tools against us. And these are the standard ones, right? So this is the normal ransomware crews. Something that should really stand out is Blackbuster and Lockbit. They're still high, and GCHQ shut those down halfway through the year. So in 6 months, they've done as much damage as others. But you can see there's a whole host of very sophisticated attackers making a lot of money, and this isn't changing anytime soon. So again, you need these tools, you need these detection engines or whatever SOC or MDR needs to be backed by someone that understands these crews and does a lot of work to build engines based on their TTPs. Incredibly sophisticated. So the evolution of cybersecurity. So this will take me a while to build out, but you get level 0, which is manual triaging, and hopefully no one's in that space, but you could be. And then 5-10 years ago, people started building rules, and that's kind of the evolution of SOAR. And what we're seeing now is, I'd say most companies I go and talk to are between 1 and 2, right? Somewhere between there. So they're starting to embrace, machine learning or generative AI or some agentic. So there's AI-assisted detections or general generative AI natural language queries. But there's more. So limited autonomy, I very rarely see this, and we have some customers that approach this in part of maybe their cloud as part of their CI/CD pipeline. No humans really should be in there, so they want the detection and response to be automated as well, right? So limited autonomy, and then we have full autonomy. So there are companies out there that will embrace this full autonomy, specifically if they have no staff or lack of resources. They'll have to put it in because they don't. And sometimes it's nighttime, right? So I still see enterprises out there, quite large ones. It's worrying where they don't have anyone that works at night, or there's a couple of hours between shifts where no one's looking, after the real estate, and it's quite quite scary how many I find, right? So a lot of people put full autonomy in because they don't have anything else to do, and they don't have a SOC team that will work 24/7. But then you need to make sure that you have an MDR service that runs behind that. So strategic pillars, when reshaping a SOC has become a very big amorphous blob of interconnected systems, and that has worked quite well. But we're starting to see a consolidation into kind of one platform. It used to be that you'd have your SIEM, or your data platform. The security data would be just sort of bolted onto another data platform, and it was kind of like, the unforgotten cousin, so to speak. And the business cases and the use cases were business, and it was kind of bolted on, and it became a bit of a problem. We're starting to see a unification of that, so all data going into one place, because that data needs to be readily accessible, all hot, and interconnected with everything. Detection innovation, I've really talked about that. AI-driven detections as well. Things like grey listing, first seen, UABA, looking for anomalous behavior, because we don't have time to continuously write SOC and SOAR and SIEM rules. And then SOC automation, so automating this as much as possible, giving the user feedback. So maybe you get the human in the loop, but they get a lot of information so they can quickly make a decision, and you can triage more incidents per hour than you could before. And you need layered security like static AI, behavioral AI, right? These things work at speed, so your computers can do what they're supposed to do, and they're performant and they function, right? You can't have too many. We've all seen those computers with 4 or 5 security tools on that barely work. And it used to be 10 a.m. on a Friday, you'd go and have a coffee because there'd be a scan of some sort and your machine doesn't work. So you need performant security tools that use AI so that it's the machine continues to function. Things like platform detection rules. Threat intelligence, I don't like that for detection. It's a really sort of old, bad way of doing detection. I like it for attribution. So once you've detected something, then you can go, all right, well, that hash is related to, APT29 or whatever. So then you can kind of, right, not only do I know what it is, I know who it is, so now I can work out maybe their intent, right? So then is it a nation state? Is it financially motivated? Shall I escalate to the ASD, ACSC? That's kind of my use of threat intelligence. You can use it however you want. And then platform anomaly detections I mentioned, and then auto triage and auto investigation, which is, as I said, that attack chain. You can start to build agentic workflows doing that triaging, and that will be coming in our Athena release, where we'll do agentic flows across the different surfaces that you have. So I'll quickly go over static AI just to remind everyone what it is. Again, I didn't want to go too much over our technology, but people talk about AI, but they don't really understand some of the components. So supervised ML, we started in 2012, and we were talking about neural networks and machine learning back then, right? It wasn't AI, it was specific disciplines. So what a static AI model is, or technically supervised ML, is we'll break apart a file, and a file can have 1.6 million different variations. So what was happening in the signature world is you would have a hash, and it's really easy to change a hash or an IP address. Once that was changed, there was no detection. So if you're looking for 1.6 million things, the attacker has to change a whole lot of things for you to then not detect it, right? So it became really hard for the attacker to evade detection. And the things they had to do was quite sophisticated, and use of that, like obfuscation, was another signal, right? So even when they tried to make modifications, the modifications themselves caused other triggers, right? So static AI is really resilient against attackers. And what we've got here is, so we take each feature of a file name, file path, hash, all the bits and pieces, how it's coded, language structure, and we take that and we model that against the static AI model, and then we'll project it against the model. And here you can see, so the verdicts we make is malicious, suspicious, benign, and unknown, and that's kind of what you want from your products. And then what we started to see is different types of malware would cluster, right? Trojans would kind of cluster together. Ransomware would kind of cluster together because they do the same sort of thing. And then we could do attribution, or we could do categorization of the type of malware. So instantly we could say, okay, well, it's malicious and we think it's ransomware. But the problem with that is when the machine says no, and it's a machine learned model, who knows why? You know, the model just knows it was statistically likely to be ransomware. But then you have to make a determination. So then we have other models, or you should have other models to unwrap that and give you that response in English. And then you should be able to, I've highlighted things in red that as a threat analyst, I'd be like, these are the things that I'd be looking at to investigate further. You know, you've got abnormal number of operations to suspend execution. That's kind of not normal. File references, which means they're looking at files. Again, that could be normal. And then, oh, there's a random number generator. Okay, all right. Well, maybe it's encrypting its old stuff, or it's encrypting other people's files. But maybe I should look at that, right? So those are kind of the TTPs I'd be looking for. And on the behavioral side, process around system information discovery. Again, pseudo was used. That might be normal, but it's something to look at. And then you've got persistence mechanisms in there as well. So again, okay, well, maybe that's why detecting is bad. And these are all mapped to the T numbers, which is the MITRE attack framework numbers, which is a taxonomy you should all use when you're sharing information between your different organizations. So we were attacked by T1074, and then you can look up what that is. So you need to be able to have the machine work out what it is, but then give you that information in a format that you understand, so you can decide whether it's a true positive or a false positive. And this all maps to the pyramid of pain. As I said, the TTPs at the top are actually the hardest thing to give the SOC analyst, and the rest are trivial to change. So you really need to be trying to find a platform or a service that really gives you the tactics and techniques. Which leads me to the age of the bloated SIEM cartel is over, right? So we're now starting to see a consolidation of those SIEM tools into a fit-for-purpose cyber platform, right? All of the tools, all of the actions in one place, giving you the response in natural language, analyzing things, summaries, in a platform that's fit for purpose. So the old systems were, high cost. Everyone was pumping everything into the SIEM, and then you ran out of, space, or your license constrained, and then you really didn't have all of the information. They were highly complex. You'd even hire people to do indexing of the tables that you had and building out tables, and you had to try and normalize all this data, right? So, today, we don't have an index. We don't have anyone that fixes our index because we don't have index. It's indexless. So it's like indexed on the fly. And that's the kind of thing you can get from a cloud service, right? So it's lightning fast. You need these systems to be lightning fast, because in the age of agentic, if the machine is asking, very similar to API, if your API is slow, then the interconnected applications break because the API gave you the information in a slow way. If you've got machines asking questions, and they'll ask in an agentic way, they'll reason, they'll start asking multiple questions, then you need the back end to be lightning fast. And it needs to be efficient, right? So I think the old system where you build queries, run queries, wait 5 minutes, go and get a coffee, like those days, a SOC team can't really, wait for that, right? We had a customer that we ran a demo, we ran a query. It took 3 minutes to run the query, and we apologized for how long it took, and the customer laughed, and he said that normally takes 3 hours. So I'm happy with 3 minutes. So we've come a long way with the speed that SIEMs work. And transition away from pipe it all to SIEM, right? So we used to try and keep everything, and that's a big problem. So collect only relevant logs, prioritize low volume, high value, even risk attributed data, right? Try to start with, you do rich data, because if you bring everything in, you might need it, but what you'll do, it's like when you fill your kitchen drawer with stuff, right? When you want something, you can't find it because it's full of junk. So that noise to signal ratio is critical. So try to make sure that you only bring in data that is relevant and is enriched if possible. And then, if it's like switch traffic, high volume, low value, then don't bring that in, right? You might want to pipe that to an S3 bucket if you want, but don't bring it into your threat hunting scene platform. You might need that for forensics later. High value, and then reducing that noise. The noise will kill you every day of the week from a business perspective. There's been so many breaches where the signals were there, but they were just hidden in the noise. Look for things like the use of OCSF, the Open Cybersecurity Schema Framework. A lot of companies have come together and decided on a JSON framework for what a username is, what an IP address is, the values, the key pairs, so that when you're running a query and you say, please give me anything which has a destination IP address of this, then it doesn't matter whether your data came from Fortinet, Palo, SentinelOne, CrowdStrike, Defender, it will respond and give you all of the data, right? You don't have to build queries based on the type of data you're ingesting. Try and normalize that data to something like OCSF. And the beauty of that, once you've got standardized data, then you can model it. You can train models on that. So our generative AI works really well. So if you bring in any data that's OCSF, we don't have to train it because our generative AI models are trained on OCSF. So you can start, querying away. So improve for AI, but then it also improved for hyperautomation. That was a nice addition to normalizing. If you have a playbook and it's standardized and it's normalized to OCSF, then you don't have to change the playbook based on whether it's Fortinet or Palo, because the automation can see that. Maybe the API connecting, if you want to do automation of the firewall, that will need to change, but the playbook itself, is standardized. So this is something that's come out of this. So I've talked a little bit about Agentic AI, and in RSA everyone was talking about Agentic AI. So what is it, right? So it's like generative AI. So generative AI is something that generates. So you have to give it some content, like I want a picture of a cat, in a snow scene, and then it will generate. It will generate a picture for you. Whereas Agentic will start to take information and then generate on its own. And then it will take the output of that and then ask another question. If you want some fun, there is an Agentic process where someone said, please generate me a random number. And computers can't generate random numbers. So it just kept going through this loop of reasoning that the number that it just generated is actually predictable because it's a computer, and it just keeps going and going and going. But it's quite fun, some of the ways it tries to generate random numbers. But the reasoning actually works. And then it understands, all languages. And I'm not talking about Python. I mean, Japanese, Chinese, English, French, German. So you can have SOC analysts of, any nationality in any country being able to threat hunt this data. And then workflow optimization. Obviously, it's a machine, right? So it can optimize workflows better than we can. And Agentic AI is where we'll see the SOC of the future being able to do from an endpoint to identity to cloud, and then tell you where the red. If you come to the booth, we do have a demo of the Athena Agentic flows later on. I don't have time to show you today, but come over to the booth if you want to see that. And what is Agentic RAG? So that retrieval augmented generative AI. What this, I think agentic knowledge is, I think something Microsoft calls it, but it basically means that the model has knowledge bases. So when you say, please give me anything to do with lol bins, the model doesn't know what a lol bin is, so you have to have a dictionary of what a lol bin is, right? All of the different, and that will update. You don't want to update your model because that can take a week and $10 million, so quite expensive. So you want to have knowledge bases that update, and those knowledge bases, you really need them to be not internet-based, because if they're internet-based, then they can be poisoned, right? So try to have your knowledge bases like localized and trusted. So your lol, don't. I've seen a lot of agentic things go out to the internet and bring them in. I wouldn't have that in a SOC, right? So you'd have the MITRE taxonomy, lol bins, maybe your support desk documentation. So that it basically accesses external knowledge to enhance the query. and then it can improve that. So you can say, how do I install the agent? How do I run a dashboard? So you can look at your support documentation and your knowledge base. So when you look at the agentic AI world, the stuff that we're working on now, and I look at a SIEM, because I used to build SOCs I was a CTO of a company, I had to build a SOC, then I became a CISO. If I look at the disaster that I built like 10 or 15 years ago, right, and I'm looking at a SOC today, they're chalk and cheese. So basically the agentic world makes the seams of the past look like a data swamp. It's completely different, right? So there's a lack of structure, there's missing context, and it really does hinder an analyst, right? They have to dig through the telemetry. And if you've got, say you have an IAM console, and you want to reset a user's password, switching from one console to another, that could take a few minutes. Then you can, rather than looking at Wayne Phillips, you might look at W. Phillips, and that's Wendy Phillips, right? So the humans switching from one console to another, manually disabling accounts or passwords is rife for human error and fraught with danger. So having these agentic systems make it effortless. And here's some of the differences between the two. Obviously, data overload, manual parsing, noise. We even have automated parsing now, right? So we have models. Luckily, with generative AI, we can give it log files and say, please spit me out a parser, and it can spit out an OCSF parser. We'll be bringing that to the platform, so you can just upload any logs. If you've got an application, you just upload those logs, and it will spit out an OCSF parser for you. So we're now trying to make the onboarding. It's not released just yet, but yeah, that will be coming soon. Efficient workflows, signals rather than noise, and then accurate true positive. So again, reducing that false positive or improving that signal to noise ratio. So really, the agentic world is out there, right? We're now seeing attacks. So the dwell time 10 years ago was like 200 days. It's come down to, actually the last 2 years, it's been hovering at about 50. But we have seen an attack that was from go to woe under 5 minutes. So as your SOC team was standing up and going to get a coffee, go to the toilet, go to the water, it doesn't matter what your SLA is. If they can come in and break through an attack and move laterally in under 5 minutes, then you need to automate that, right? There isn't a human on the planet that can triage and work out what's happening in under 5 minutes. So the attackers, as the speed gets quicker, you need to think about automating this. How much you automate? Maybe it's just at the machine level you automate, and then escalate up. But automation is critical now that the kind of cat is out the bag. So legacy SIEM, human-assisted agentic AI, and hyperautomation, and then you can use generative AI to build hyperautomation, right? So at the moment, I think it's tipped in the way of the defender, right? So I don't think the attackers have actually, spent enough time. But once they do, then this will be, in 5 years' time, this will be normal. And in 5 years' time, we'll be looking at that quaint time where we used to have indexes and tables and laugh, right? So this will be the norm. And security is rife for this, right? It's a very complicated, highly technical discipline. So giving you the SOC analyst the information in natural language is critical, right? Automated task, AI-driven insights, and integrated systems, right? These are all the hallmarks of the SOC of the future, and something you should be looking at when you're designing or building or evaluating, right? These are the things that should be in your RFP for next year or your next budget cycle. So really, elegant design in cybersecurity. As we started bracing this, the consoles look nicer. They give you information in the language that you speak. They'll do summarization. They'll do the percentage of likelihood of it being a true positive, right? So you get a concept of master of experts. So you get multiple models, and then you get a model saying, based on these 5 models and this other data, it will give you different answers. So you don't have to just trust one model or one machine. We can have the information from multiple models, and then you can make that determination. Awesome, and that was it. So the future's looking bright for a SOC. Any questions? Fire away.
Earlier you said Good. Yeah.
Earlier you mentioned not collecting everything, and you did touch on the idea of like forensic analysis.
Yeah.
If you do need to collect everything, that you can dump that somewhere.
Yeah.
What recommendations could you have for what kind of systems would be most efficient for rehydrating that?
For rehydrating that.
Yeah,
data.
so that you can perform that analysis at the investigation time.
Yeah. So the way I look at it is like it's a rubbish analogy, but it's like if I haven't worn something in the closet for 6 months, if I haven't forensically analyzed my switch data, then I don't really need to spend time, bringing it into my hot system. But you might, for compliance reasons, if you're regulated and you need to keep that data, then you can put it somewhere else. S3 or some sort of cloud storage is the best place for rehydrating, because there's a lot of tools to analyze S3 buckets in JSON format and then bring it into multiple systems, something like OCSF. Then you could bring it into any system that understands OCSF, not just Sentinel-1. You could take it to us, then put it into Elastic and do some analysis in Elastic if you wanted that on-prem or Splunk or something. But yeah, it would be like, as long as the data is in OCSF and then in a cloud-native form.
Is there an idea that you might be able to have Agentic AI do that in, or maybe not Agentic AI, but certainly
absolutely.
automating that process to say, hey, this incident requires more information. I need to go back further. I need to collect more of that noise that you would ordinarily see from a detection perspective. Is that
you could absolutely do that. Yeah, and look, a lot of customers, as we're trying to innovate, people are like, well, you haven't got that feature, we'll just hyper-automate it. So we got customers like building flows into our product that we just haven't had time to build yet. So using hyper-automation is a perfect example of that. Looking at, well, I have this incident and it looks like network traffic. Maybe I'll need to rehydrate some of my switch traffic while I'm going to recorded future and Mandiant to do like threat enrichment, so I can see if there's any IOCs out there. And maybe at the same time you go to look for 3 or 4 sources, bring that in. If they're all high, then create another alert, right? So you can, based on the information, you can create another alert that has more information. So the scope is almost endless. I don't want to scare people by saying that you can do crazy things, but you can create alerts based on enriching other alerts and then elevating them from a low to a critical.
Literally just thinking now from an Agentic AI perspective. An Agentic AI says, I found something suspicious, this requires more investigation, and then it fires off another automation that goes and enriches that data for
you come to the booth, the Athena, like it literally does that. So you can say, fire it off, I'll look at process migration, then I'll look at lateral movement, then I'll look at identity, and then at the end it gives you a summary of what it thought. Yeah, so the agentic workflows are kind of there already.
We've got time for one more question. Anyone else?
Can we use Agentic AI for detection engineering tasks?
Detection engineering. Oh, well, you could. I'm trying to think of a use case of like what kind of, like if you've got a payload and you want to,
Anything aligned with MITRE frameworks, what gaps we have, and what detections we should, use cases we should be prioritizing.
Well, we definitely did. That was actually a good use case of we saw something that was suspicious and then we enriched it and it became more suspicious. So it's kind of improving the detection. And you have different detection types of static, behavioral, threat intelligence, and then you can kind of go. The agentic bit could knit all that together and give you a fuller view. So very much in the detection, but you'll need to have a detection. The agentic stuff we're working on now is things like, the AI stuff is rather than a large language model, we're working on little language models so we can get generative AI to work on an endpoint. It's hard to do that without compute, so this may be a long R&D cycle, but yeah, we're definitely using Gen AI and Agentic AI to try and improve detections.
All right, could you please put your hands together for Wayne?
Thanks all. Cheers.